Alright, another draft physics video. Yeah, this one again on the subject of the consistency of these principles of quantum mechanics. And it's something like the relativity arguments. You can make arguments that there's paradoxes based on just doing logical progression. What's the logical implications of the theory? So I could make the same argument that the lensing, galactic lensing, whatever, spatial lensing that's supposed to take place, that all of NASA and all the physicists are convinced happens as a fact. There's huge inconsistencies in that it would have a consequence if it's doing what they're saying is happening. There's a consequence to it. There's certain things that would be unavoidable, that would have to happen just by the laws of probability. And like objects moving into these lenses and there being huge magnification of those objects, and we'd see these kind of phantom blobs of light in more images of deep space instead of these very select and mostly very detailed lensing objects. So I haven't heard in my opinion, a valid response to that, pointing out that there's an inconsistency in the data, that it's like the principle somehow doesn't really apply, and that we're just going to use it for a special case. So in the special cases we'll look at it and we'll assume lensing, but we won't look at all the evidence, and we won't recognize that there's inconsistencies in that evidence. Alright, so then the interferometer brings up another of the same problem, because compared to the two-slit experiment and all the logic that goes into that, which is, I guess, just briefly, it shouldn't really require any explanation. This holds true for two-slit, single-slit, doesn't really matter, but the idea is that single photons go through this experiment and create the result. So essentially the single photons interfere with themselves, and technically the Copenhagen explanation would have it, you believe, that the single photon in some manner or other creates some part of itself anyway that ends up going through both slits and creates a spherical wave somehow, and that the spherical wave creates the pattern. That these two objects go through space and interfere with each other and create the pattern. But it started with a single photon, not two photons, nothing like that. So the quantum mechanical explanation is this is a property that single photons have. And there's no evidence that you could send in multiple photons, have them create some sort of wave function, and that would interfere with each other. So there's no experimental evidence I know of, or anything I know of, besides entangled photons or something, where you could take two regular photons, do something to them to make them interfere with each other and create interference. Yet the assumption built into the interferometer is exactly that. And I argue it's just an assumption. It's just, well, we just changed the rules. We're just saying that now we're not doing that single photon stuff anymore, even though it's the entire foundation of the theory. Because the theory is based on this Heisenberg idea that if I make the slit narrower, wider versus a narrow slit, well, you can't see that anyway, the narrower I make the slit, the more the light diverges as the photon rejects being localized. And no, I'm not saying it rejects it on purpose. I'm just saying their theory is that there's this relationship, and I would concede the relationship exists, but they think it's a property of the photon, which I don't think it is, but anyway. And so this quantum mechanics is based on what single photons do. There's no evidence that, again, photons will interact with each other ever, that you can shoot them in any way to make two beams of light. In some way the photons would interact with each other from separate photons. But the interferometer is sort of dependent entirely on that theory being wrong, that this is a single photon phenomenon, because the entire experiment is sort of dependent on some notion, some idea, that if I did do it as single photons, there's no one speculating that the single photon would take both paths. I mean, no one suggested that that's what's really happening. And so if the photon takes the single path, it can't possibly interfere with itself, because there's no second photon taking the other leg in the experiment. So there's no, the single photon just goes through the experiment. So unless they say that the single photon in some way does go through both, they really can't make an argument. So I mean, it would be the experiment to get done is the, and I'd ask the question again why these experiments haven't been done. Obviously, if they claim they can do this single photon with the double slit experiment, why shouldn't they be able to do it with this experiment just as easily? There's no inhibiting factor preventing it. And see if they also get the same pattern, that meaning that it's a single photon phenomenon somehow, and that their theory is therefore consistent, because the pattern is the same in both, whether you send a bunch of photons in or whether you just send one at a time, you get the same pattern. And then they can explain where in this experiment would have to be right here, it'll have to be at the beam splitter, and then they can try to explain how the photon decided to go through, to take both paths, to be reflected off a piece of silver, or not to be reflected and go through the gap. Because there's no evidence photons will do that in any other circumstance. So yeah, I just don't think there's any chance that that's going to be the conclusion. I think the conclusion is going to be that yes, you get the same pattern, and it's for a reason though. It's it's not because there's photons interfering with photons. So there's not, like by their theory, two photons have to go through the experiment. One takes this route, one takes this route, and then they don't match each other coming this way. And one of the huge assumptions in this experiment too is that they have sources of light that are producing light that is so perfectly in phase that they could measure changes in that phase. And I don't even think they've demonstrated that that's true. To be able to tell the subtle differences of little changes in a couple of these photons in the stream or out of phase, and somehow they can detect that little subtle difference in a few photons that are now more out of phase than the rest of them were out of phase, because I don't think these lasers can produce light that's in phase that well anyway. So the other problem is the sort of the distance subject. So because that gets into this, it gets into relativity. So I would argue that if you're just using the device to measure movement in a mirror, some sort of back and forth movement in the mirror, it wouldn't matter how far you made the distance. It wouldn't enhance the device in any way, because all you're really measuring is this little phase difference. You're just measuring two photons that are, coming into a circumstance out of phase or in phase. And that little difference, just you're not going to enhance the experiment any by creating more distance if that's all you're measuring is a phase difference. Now, I would argue if you're measuring something like how much the light diverges, that is, how much it separates, that is really dependent on how far away you go. Like in the two-slit experiment, you get a better view of the results the further away you put the target. You can see it better. You can see any changes. You can see more detail. And the same would be true for this interferometer, in the sense that the further away the reflecting mirrors are, the bigger the pattern you get, and therefore the more detail you'll be able to see in the pattern. So that would make sense as just being dependent on divergence, though. It's not dependent on the photons being necessarily out of phase. It's just that you can see if they are better if the mirrors are further apart, theoretically. But their theory is that most of these measurements they're doing aren't about like having the mirror connected to something where it's picking up vibrations from the external world. They're using the experiment to measure the distance between the beam splitter and the mirror on different lengths. And so their theory is that there's a bunch of photons in this path, and that space is somehow expanding between them, so the photons are contracting, so the photons are getting further apart from each other, and therefore the more photons you have, the longer the distance, the more all these little bits of space would add up, and you'd end up with a bigger resolution after that happens. So you have to accept that that's their theory, that you really think that's what happens in the universe, that space just gets created between things as small as a photon and red shifts them or blue shifts them, all of them, in the space between the two objects. Like every single one of the photons somehow gets red shifted as it's moving. So then, yes, the longer the path, the more signal you'll get, because you're adding the space in each photon, and that would add up. One photon would only be a tiny amount of distance, but all the photons would add up to more distance, so we end up with a total of more distance. So clearly I think this divergence thing is a lot more reasonable as an explanation for what you're detecting, is the separation of the light. And what you still have to have a theory for why does one beam affect the other beam. And I would argue that goes kind of back to the electron argument, that you're pushing light. Unlike the two-slit experiment, there isn't something coming back and hitting the slits or hitting the material. There's nothing interfering. And in this experiment, of course, there is, because the stuff that was transmitted the thing that went through the first time, is going to be reflecting when the second thing goes through, and so they're interfering. There's a point where they're coming back to this same point, and they're going to hit something close to what the other guy hit. They're both going to be hitting material one way or the other, glass. They're going to be hitting whatever the reflective agent is, so a transmission medium between two prisms, depending on what kind of beam splitter you use. But they're both going to be hitting that medium at the same time, theoretically. And clearly, by my own theory, is photons as solid objects, if you put them out of phase, it means one beam's going to hit it 1 millisecond, and the other one's going to hit it the next, half a phase or whatever, and that they could be hitting things in opposite sides, because one's reflecting and one's transmitting, and therefore that could mix in terms of the effect, because you're basically hitting let's say you're hitting one electron in, and on the other side you're hitting one atom up, you could multiply the effect, and if they hit at different times, you could have the destructive interference thing where the effect of one rebounding is happening exactly the same time the other one's hitting. So one side's rebounding the same time the other side's hitting, and that would be a constructive interference. They'd both end up moving the same way. So it's really just about the surface being disturbed, and the fact that you're sending a second beam in. The first beam's disturbing it, and then there's a second beam that's disturbing it, and that's where the two effects of energy are being mixed, and to create your mixed result. So it has nothing to do with photons or Copenhagen, Heisenberg, any of that kind of stuff. It just has to do with both energy and the medium is a place where the energy can be converted, and so the two photons aren't really interacting with each other. They're both interacting with a medium by hitting it, and they're in close enough proximity that the effects of their impacts are affecting how they're going to leave, or whether they're going to be transmitted, or whether they're going to be reflected, because they're changing the surfaces as they hit it. So it's just so I think a mechanical theory can explain why the photons appear to be interacting with each other when they're really interacting with a medium. So, you know, there's photon hitting this way, there's photon hitting this way, and that's affecting the medium, which is going to affect how the electrons behave, and how the electrons behave will decide how the new photons will be emitted, whether they'll be transmitted or whether they'll be reflected. Yeah, where they're going to hit on the surface, or what they're going to hit on the surface. So anyway, the key point is you know, these people who, you know, are so aggressive in defending what's happening in this experiment, they should be able to say one way or another. Do they believe this is a quantum mechanical experiment, or do they think it's doing something different? It's doing a new kind of quantum mechanics where different photons interfere with each other. So they should be able to say one way or the other what they think is happening, and then they should be able to tell me what they think, because I can't find it on the internet anyway. I can't find an experiment where they did a single photon experiment with an interferometer, nor can I find any explanation of an interferometer that goes into, except for the ones that are really optical, you know, really I don't know what they call it, spectroscopy or something, you know, where they're really just using the refraction between two reflective surfaces, like two mirrors are really close together, or some other mechanism to create some kind of interference. Clearly there's no interference in those experiments, it's just about refraction. But I can't find any explanation of a standard interferometer, or any of the variations that have to do with reflecting light back, that explain exactly where this interference happens. You know, where does the probability wave, that is a quantum mechanical function, where is that function in this experiment? Where is the probability wave created? And you know, they often say things like the interference will happen at the target. You know, even that's kind of a cop-out, right? Because no one really theorizes that it isn't until the photons hit the target that it's decided where the photons are going to go. You know, there's a pretty unanimous assumption built in that if it's decided anywhere, it's decided at the slits, where Huygens creates these extra wave properties are created that can interfere with each other. So where in this experiment do we create these wave properties, and where do they interfere with each other? And if you're saying it happens here at the last leg, at the target, or right before the target, then you have to explain how a single photon took both these paths. And if you think it happened somewhere earlier, then you have to explain how that beam splitter created two photons, to how it turned on the photon's wave properties. Yeah, I guess that's the way to say it. It's clearly in the half-silvered case. I'd argue that when you go through the half silvering, you're going through a small aperture, and you're automatically going to start creating two photons going one path, but that doesn't explain how two go the other way. So it's just a huge inconsistency with the general theory. So if people are going to so ardently defend quantum mechanics as the most proven math in the history of mankind, the most solid theory, it's just so frickin' perfect, it just can't possibly be wrong, then how can it have such gross inconsistencies in its underlying theory? How can it be based on axioms you change depending on the experiment you're doing? If it's so good, if it's so reliable, so solid. Yeah, that's a satirical question, really. but what's the answer? How do you explain the contradiction in perception? In the single slit and the double slit experiment, we are to understand its single photons, and if you were to think that extra photons are interfering with each other, that would ruin the math, actually, because then you'd have the problem of two photons in very different, caught in very different probability waves interfering with the interference. They'd end up ruining the interference pattern. So it can't really work that it does both. So either you believe that single photons are where the magic is, and if you think multiple photons are, well, that's not consistent with the single slit or the double slit in terms of interference patterns. And as I have pointed out, the pattern of interference seen in this experiment is a lot different. It has so many different kind of manifestations. I mean, depending on what you use as a beam splitter, you can get just bars, on bar, off bar, on bar, off bar, or you can get a pattern of a bullseye, and but the key is the bullseye gets smaller and smaller as it gets out bigger. The rings get tighter and tighter, so it doesn't really do what the interference pattern is supposed to do, which is be consistent, and that's really not explained either. So I have lots of questions. I guess nobody else asks questions, nobody cares. They just accept and say, yes, we just will believe. There's a Bible, somebody wrote it, must have wrote it for a reason, therefore it's probably okay as a story. And there's a lot wrong with this story. So, yeah. Probably the last, I keep saying it will be, but it won't be. I will ask Hafladay, I mean, I thought I made it clear in the last video, what kind of beam splitter did you order? The cube kind or the flat kind? Jeez. In case I'm going to buy one, I don't think it'd be bright to buy the same kind you got. But anyway, okay. So, until the next time, and such, so forth and whatnot. Yeah, I'm going to do some experiments and stuff, but I'll try to stay off this subject and move on and such. But I wish these people who keep shoving this quantum mechanics in my face, I mean, how do they keep, he posted another, from documentary kind of argument, and you're saying, what is your argument? So he posted a 20-minute video, I mean, whatever, 9 minutes, 7 minutes or something, some clip from a documentary, science, whatever, and there's no understanding of what he thinks of what the guy's saying. Are you for it or against it? Are you selling this crap, or are you pointing out how there's holes in it? I mean, what's the point of posting an ambiguous argument and then being ambiguous about whether you think this means something. Does it mean something that there's evidence of inconsistency in the application of these rules? Shit. Anyway. Enough. So anybody who can post a link to some explanation that explains where the interference takes place and a rationale for it, or if they have some knowledge of single photons ever going through an interferometer, I would appreciate knowledge of it. I mean, what they clearly have, which kind of just eliminates the whole idea of this single photon having anything to do with this, this having anything to do with true interference, is they've dealt with fiber optic cables. So, they take one fiber optic cable goes through the bend, pure, just a bent cable. The other cable, they open it at the end, take away the bend, and let it reflect off a mirror, and then go back into the cable. I mean, clearly a single photon can't do that. So it clearly has to be different photons interfering with each other. And again, the argument is where are they doing this interference? I mean, I'd even say that the fiber optic, well, I'll draw it. I mean, it was, when you think about it, that doesn't sound like it's possible. That can't possibly work. Well, that won't work. I have to get a new piece of paper. Oh. So much to do, so few me's to do it. Alright, so the experiment is something like, they always put lenses and stuff, so that's sort of a piece where everything goes south. So you have a light source, a couple lenses, and you have these two fiber optic cables. Alright. So one of them is continuous, and the other cable is broken. And it reflects off a mirror, and then goes into another cable. And then they get a pattern here of some kind. Who knows what. I haven't seen the pattern they actually get. So the light is in one path just going through the cable, and the other path it reflects off the mirror and goes into the cable. Now the problem with this whole experiment is that fiber optic cables do this to light anyway. So it's bouncing around quite a bit in the cable. But yeah, so I haven't seen the results, but I'm just saying an experiment like that makes it pretty hard to believe this whole wave single photony thing. But this would also create a problem of figuring out where's the interference point. How did these two interfere, and you're stuck with here. And if you're going to say they interfere in space, two different photons interfere in space, we should be able to duplicate that in some other experiment where we can make photons do that. How come they can't do that? That's all. How come regular photons, there's no evidence that no matter how I smash them together, I can make two individual photons interfere with each other? They always have to go through a medium. And even in this experiment, where's the medium? If you had a mirror here or something that they both hit, well, you got some chance, but there's no medium, there's no nothing. It's two sources now, one beam coming out of one, the other beam coming out of the other. How can you make those interfere with each other? That's like having two lasers shooting at each. Can't make them interfere. So what's the theory? I don't see one. So anyway, I don't see quantum mechanics explaining this. I see perversions of it, and new versions of it. They don't have a consistent three bear story here. It blends into Goldilocks. Goldilocks blends into Little Red Riding Hood, and it blends into the Three Pigs, and then some kind of grim nightmare thing, and they just the little story changes as they need it to, and that shouldn't be the foundation of scientific. I don't know. It shouldn't. The foundation of science should be a lot more solid than that. You just change the game rules depending on the experiment. That just isn't right. No, not right.